Welcome back. In this video, we are going to discuss pointer expressions. In order to discuss pointer expressions, we'll discuss one program, C program. So, let us say this is a very simple C program. In this program, we are declaring a variable A, integer type variable A, to which we are assigning value 5. When compiler reads this, or this tells compiler to allocate the memory required to store an integer value. So as we have seen, to store an integer value, we need 4 bytes. 4 bytes of memory will be reserved, and that will be named as A. Those 4 bytes will be named as A. And then we will assign value 5 to that A. So 5 will be stored in A. So this is what happens with this statement. Now next statement, again we are declaring one variable B, but this variable B is a pointer of integer type. That means B is capable of storing an address of integer type variable. B is an integer type pointer, right? So this star in the declaration tells the compiler that B is not an ordinary variable, it's a pointer variable. That means B is going to store address, memory address. It's not going to store a normal integer, float or character type value. It is going to store an address, and whose address it's going to store? Another variable of integer type. That's why B is an integer type pointer. So as B is a variable, so B will be allocated memory. How much memory B will be allocated? B is a pointer, so pointer requires 8 bytes of memory, as we have discussed. So 8 bytes of memory, wherever it is free, will be allocated, will be reserved. Those 8 bytes, let's say starting from 6000 memory address till 6007, will be reserved, and that will be called as B. So this is what happens with this, right? Now we have integer type variable, we have integer type pointer, we can store address of A in B, right? So how can I do that? Address of A I can get by saying address of operator, by using address of operator. So address of A is assigned to B. So address of A is 5000, as we have discussed. As there are 4 bytes here which are named as A, but we will get, or we will retrieve, or this address of operator will retrieve only the base address, right? So this 5000 base address will be retrieved by this, and that will be assigned to B. That means that will be stored in B. So B here, this address of A, which is 5000, will be stored like this. So this is what happens with this statement. Now let us print some addresses and values of the variables. Now this printf statement, printf /n, because we are going to print a new line, address of A is equal to %p. Now in order to print addresses, memory addresses, we are going to use a format specifier called as %p. We are not going to use %d, %u or any other format specifier, but we are going to use %p, right? And that will be replaced, this format specifier will be replaced by address of A. What is address of A? 5000. So this will print 5000. Address of A is 5000. So again, I'm telling these are just the notational addresses. They are not actual memory addresses. Actual memory addresses are hexadecimal. For simplicity, we are using integer memory addresses, right? Similarly, this statement, address of A, address of A, again, what is the value of B, right? Value of this will print value of B, right? Value of B means this thing. Value of B means this thing. So this will give us value of B, and value of B is nothing but address of A, right? Value of B is nothing but address of A. So this is value of B, this is address of B, right? This is value of A, this is address of A, right? So to B we have assigned address of A. That means value of B is address of A. So address of A is equal to B, right? We are not getting address of B, we are getting only B. Only B is nothing but this 5000, which is nothing but address of A. So again, this will print 5000. Now address of B. How will I get address of B? Ampersand B and B, that is address of operator. Address of B will give me address of B, right? So that I'll print, which is 6000. Now value of A. How will I get value of A? Simply say A, we will get value of A. This will print 5, right? Now value of a, again, how can I get a value of a? By using now address, right? So value of a is equal to value of, this is the value at the address operator, value at the address which is given in the bracket. What is the address here? Address of a, this will be 5000, right? This will give me 5000, that is this. That means this will turn out to be value at 5000, value at address 5000. What is the value at address 5000? It is 5, right? So this will give us 5, right? Again we want to print the value of a. So value of a is equal to, this is again value at the address operator, value or dereference operator it is called as. So this will retrieve the value at the address which is here, right? So value at address in B. What is the address in B? 5000, right? So again this will be star 5000. What is the value at address 5000? It is 5 again, right? So B here, in fact B is a pointer pointing to A. B is a pointer, pictorial I can show it like this. B is a pointer pointing to A. In order to get the value of A, I can say star B. I can say star B, right? Okay, then value of B, I can simply say B, which is 5000, right? This is this. Why I use percent P here? Because value of B is nothing but address, right? So that's why I should use percent P, right? So 5000. And here the value of A is integer, that's why we use percent D here, percent D, right? So this is the small program which explains the pointer expressions, various pointer expressions. So stay tuned, see you in the next video. Thank you.